Welcome to 4.7. Today we're going to talk transformations of quadratic graphs. The only vocab term for this lesson is vertex form, and that's a quadratic equation in the form of y is equal to a times x minus h squared plus k, where hk is the vertex of the parabola, x equals h is the axis of symmetry, and a determines the shape of the parabola and the direction of opening. So the first thing we're going to be doing is we're going to write functions in vertex form. So we've got y is equal to x squared plus 6x minus 5, and we want to rewrite that so it's in vertex form. So what we're going to do is we're going to do something very similar to what we were doing in 4.5 when we were completing the square. First thing I'm going to do is I'm going to put the first two terms in parentheses. Okay? And what I'm going to do is I'm going to complete the square inside the parentheses. So off to the side, if I find b, which again is what's in front of x, which is 6, if I b over 2 is 3, and then if I square that, I'm going to get 9. So what I'm going to do is I'm going to add 9 inside the parentheses. Okay. Now in 4.5, if we added 9 onto one side, we'd have to add 9 onto the other. But now we're going to keep it all on the same side because it's no longer a 0 over there, it's y. So what I'm going to do is instead of adding 9 to the other side, I'm going to subtract 9 on the same side. So I'm adding 9 and subtracting 9 on the same side. So I'm not really changing anything. And when I do that, I can factor the parentheses, being x plus 3 squared. And then I've got negative 5, or minus 5 minus 9. That's going to get me a minus 14. This is in vertex form. So the main point here is to complete the square, whatever I add inside the parentheses, I have to make sure I subtract outside of the parentheses to keep the equation equivalent to what it was before. So I've got another example here. Y is equal to x squared plus 4x plus 6. Again, I'm going to put parentheses around the x squared and x term. Off to the side, I'm going to find b, which is going to be 4. Divide that by 2 and get 2. Square that to get 4. So what I'm going to do is I'm going to add 4 inside the parentheses to make it a perfect square. And to keep it even, I'm going to subtract 4 outside on the end. So what that's going to give me, I can factor this into my perfect square. It's going to be x plus 2 squared. And then I've got 6 minus 4, which is going to give me a positive 2. So my vertex form is going to be x plus 2 squared plus 2. Now we're going to take a look at what happens when we have a number in front of the x squared, like this negative 2x squared. So we're going to do the same thing that we did before. We're going to put parentheses around the x squared and the x term. But now, in order to complete the square, we can only have an x squared. So what we're going to do is we're going to factor out what's in front of the x squared. So I'm going to factor out a negative 2, and that's going to leave me with x squared minus 4x. Then I'm going to complete the square again off to the side. I've got my b value of 4. If I divide that by 2, I get 2. And if I square that, I get 4. So I'm going to add 4 onto the inside. But it's going to work a little differently now, because if I add 4 inside the parentheses, I'm not really adding 4, because if you'll notice I've got this negative 2 out here. Well, really, I'm adding the negative 2 times 4 in there, which is a negative 8. So I'm really subtracting 8 in this problem. So I need to do the opposite of that in the end, and I need to add 8. Okay, so whatever is in front of the parentheses, you need to multiply it by what you've added inside, and then make sure you undo whatever you get for an answer on at the end. So when we factor that out, we're going to get x minus 2 squared, and then negative 3 plus 8 is going to get us a positive 5. So this part right here is what's going to take people the most amount of time to get used to, but it's just the front number times what you've added in, and then whatever you get for an answer, just change the sign of it and put it on at the end, and then combine it like we normally have. So one more example here. Again, we've got a number in front of the x squared, so the first thing we're going to do, put the whole thing in parentheses, those first two, factor out what's in front of the x squared. So here I'm going to factor out a positive 2. So I'm going to get x squared minus 6x inside. I go off to the side to complete the square inside. So b is 6. Divide that by 2, I get 3. Then I'm going to square that and get 9. So I'm going to add 9 inside the parentheses. But really, again, I'm not adding 9 to the equation. I'm adding whatever 2 times 9 is. So I'm adding an 18 because it's a positive 18. So in order to undo that, I change the sign to make it a negative, and I put it on at the end. So plus 18 minus 18. So I need to be able to undo whatever I add in there. So now when I factor it out, the 2 stays the same. Factoring inside, I get x minus 3 squared. And then I've got 17 minus 18, which will get me a negative 1. Here is my vertex form of 2x squared minus 12x plus 17. So the next thing we're going to do is we're going to be graphing these in vertex form. And just a reminder of how we did transformations back in a previous chapter, we can shift it left or right by adding or subtracting inside the parentheses. We can shift it up or down by adding or subtracting outside the parentheses. To flip the whole equation upside down, we make it a negative. To stretch it vertically, we multiply the x squared by a number greater than 1. To compress it vertically, we multiply it by a number between 0 and 1. To stretch it horizontally, we multiply it by inside by a number between 0 and 1. And to compress horizontally, we multiply it inside by something greater than 1. So we're going to be graphing vertex form using these transformations. So when we're graphing equations in vertex form, remember we always start with the parent function y is equal to x squared, which is graphed here. And if we look at our equation, y is equal to x minus 3 squared minus 2, if you look inside the parentheses, this minus 3 says we're going to move everything to the right 3. And if we take the minus 2 outside, that means we're going to move down 2. So what we would do then, starting at the origin, we go right 3, down 2. Here's our new vertex. And then if you notice, the first set of points are up 1 and out 1 in both directions. Okay. And then up 3 and out 1. Up 3 and out 1. Okay. And so our new parabola is going to be right here. This is the graph of y is equal to x minus 3 squared minus 2. It's the y equals x squared graph, move to the right 3, and then down 2. So now we've got another example here. We've got y is equal to 0.25 times x plus 1 squared. Again, we're going to start with the parent function, y is equal to x squared. And if we look inside the parentheses, this plus 1 should tell us to move left 1. And then this 0.25, that should be a vertical compress. So we're going to compress everything, and what that means is we're going to take the y values and we're going to multiply them by 0.25. Okay? So the first thing is we move left 1. So from the origin, we move it to the left 1 spot right to there. Now if you look at the y values at where they are, so this one's got a y value of 1 and 1. Here we've got 4 and 4, and here we've got 9 and 9. So all of those we're going to take and we're going to multiply them by 0.25 or divide by 4, which is basically the same thing. So for 1 and 1, that's going to be 0.25 and 0.25. So that's going to be somewhere in this vicinity, right there. 4 is 1, so 4 times 0.25 is 1. 9 times 0.25, that's going to get us 2.25. Or I'm sorry, yeah, 2.25. So it'll be probably right in this vicinity right here. So this is going to be our new graph. You see how it kind of compresses it vertically. It makes it a lot wider than the original. So for our next example, we've got y is equal to negative 2 times x minus 4 squared plus 3. So again, starting with the parent function, y equals x squared. This minus 4 on the inside means we're going to go to the right 4. The plus 3 means we're going to go up 3. And the negative means we're going to reflect it across the x-axis. So we're going to flip it vertically. And then finally, the 2 means it's going to be a vertical stretch of 2. Okay, so a vertical stretch means that the y values are going to get multiplied by that 2. And since it is a negative, to make it easier on us, we'll make it a negative 2. So to start out with, we go right 4 and up 3. So this is going to be our spot that we start with. Okay, so instead of opening upwards, we're going to open downward. Okay, and so then instead of going down 1 and over 1, it's going to be down 2 and over 1. Okay, and instead of up 3, it's going to be down 6. 1, 2, 3, 4, 5, 6. And out 1 this way. Okay, and so our graph is going to look something like this. Okay, so that is going to be our graph of -2 times x minus 4 squared plus 3. You'll notice it's a lot more stretched out vertically, so it's a lot slimmer than the original. So for the last one, y is equal to 3 times x plus 2 squared minus 5. I've given you the parent function of y is equal to x squared. Go ahead and pause the video and graph this one on your own, and then hit play and see how you did. So for the transformations, you should have gotten that it's left 2, down 5, and then a vertical stretch of 3, which means the distance between them gets multiplied by 3. So instead of going up 1 and out 1 for the first one, you go up 3 and out 1. And then from the second to third points, instead of going up 3 and out 1, you go up 9 and out 1. And then the graph is the one drawn in black. You'll notice it's a lot slimmer than the original because it's been stretched vertically by a factor of 3.